Hello everyone, welcome to Gravity Cloud. This is Bindu and going to explore math with you. Math. Math is everywhere and math is full of addition, subtraction, multiplication, division, numbers and expressions, right? So this math is full of calculations and lot more to explore in it. And in this class, let's have some fun with the math, right? I hope you are ready to have fun with me. So let's look at fun with math. So this is Ritu. And what is Ritu thinking? Ritu is thinking, how can I multiply bigger numbers faster? You all know how to multiply numbers. But how can we multiply them faster? Let's look at it. Okay? So yeah. First, multiplication of bigger even numbers by 5. So how to multiply with 5 easily, right? Before moving into this, you all know multiplication by 10 is very simple. Suppose I have 35. If I multiply it with 10, it's just 350, right? You just put a 0. Suppose 1, 5, 4, 3, 9, 6. We have some number and you're multiplying with 10. That means you'll just put 0 at the end. 1, 5, 4, 3, 9, 6, 0. Isn't it simple? Yes. Even multiplication of 5 is also as simple as it. Let's look how. So, how is it so simple? It's so simple for even numbers and how? The thing is, you divide the full number with 2 first and then multiply by 10. How? So the number we have here, before moving into bigger number, let's look at a smaller number. So 234 into 5. So I want to do 234 into 5. This is an even number. First, let's find the division of 2 here. So 234 by 2. So 2 becomes 1, 3, so it becomes 1. And 1 gone, 14. So this is 7. 117 and just put 0. Just put 0. So the answer is 1170. Right. Isn't it interesting? Do for one more number now. 256 into 5. Again, how will we do this? So 1, 4. So you'll go with 2 and 16 is 8. 1280. That's it. Am I clear? So, multiplication with 5 means the number is divided with 2 and just 0 is kept at the end in one's place. So, let's do this for a bigger number just in 5 seconds. So, without wasting time, let's start. We'll multiply with 5 in 5 seconds. So, start. So, for 2 it becomes 1, 1, 2, 2, 0 comes as it is, 6 becomes 3, 5. So you are dividing with 2 and 1 gone, 18 is 9, right? So for 4 on division with 2 becomes 2, 3, 3, 8 becomes 4, 1, 4 becomes 2, 0 as it is and 6 comes as 3. And now we are just putting 0. So, on multiplying this, we get 112202329233412030. Such a big number with 5 seconds multiplication. So, we'll do few more sums of this kind in this session. So, let's look into one more question now. Multiplication of bigger even number by 5. So, these are the two numbers. Let's solve them now. Right. So, the number is 29306. Right. 29306. Stopwatch on for 5 seconds. So, let's divide with 2 first. 1, 4, 6, 5, 3. Right. How did I do it so fast? Let's do that also. So, how did I do so fast? 29306. 2 divided by 2 is 1. Clear. Now, 9, I cannot divide 9, I can divide 8. So 8 by 2 is 4. So 1 comes here. 13, right? 13 is not possible, but I can divide 12. So 6. And again 1 is gone. So 10, 5. And 6 is 3. So 1, 4, 6, 5, 3, right? So the answer for this number multiplication is 1, 4, 6, 5, 3. Am I done? No, we need to put 0. 1, 4, 6, 5, 3, 0. Right? Let's solve the next bit now. So 5, 4, 5, 9, 8, 6 into 5. So again, first divide it with 2. On division 5 by 2, we get 2. So 1 carried. 1, 4, 14. So 7. 5 again. So 2 2's 4 and 1 carried. 19. 19 cannot be divided by 2. So we'll divide 18 and write 9. And again 18. So 9. 3. And now since we are multiplying with 5, so after dividing with 2, we need to put 0. That is, we are multiplying with 10. So the answer is 2729930. Clear? So I hope you enjoyed have to multiply numbers by 5, even numbers by 5. Even this process can be done for odd numbers, but there on dividing with 2, we will get decimal first. Okay? So there it may not be so useful, but for long even numbers, this is very easy trick. Now, let's look how to multiply by 11. How to multiply bigger numbers by 11. Okay? First, let's do for 2-digit numbers. Multiplication of 2-digit numbers by 11. So, 29 into 11. So, when you are multiplying by 11, what exactly happens? So, normal multiplication shows 29 into 11. So, 9 into 1, 9 into 2. Again 9 into 1, 9 into 2. So, 9, 11, 3. 3, 1, 9. The same technique is used without writing all this. How? Whatever the digit is. Now the digit is 29. So whatever the digit in ones place comes in the ones place first. Now, in the tens place, what will come? So we get 2 plus 9. What is 2 plus 9? 2 plus 9 is 11. So 1 and 1 is carried. Then tens place into 11. That is 2. So 2 plus 1, 3. Right? So let us do for one more number. 54 into 11. So this is going to be a 3-digit number where first place is 4. Ones place is always the ones place of the digit. 4 as it is. Coming to the tens place, 5 plus 4, which is 9. And then hundreds place is the number 5. So 594. Let's solve for one more number. So let us take 66 into 11. How to solve this? Again, 3 digits. So ones digit is always the ones digit. 6. Coming to the next place. 6 plus 6, 12. We cannot write 12. So 2 and 1 is carried up. And the hundreds place actually is 6. But we have plus 1. So we'll write 7. 726. Clear? So multiplication of 11 is with, for 2-digit numbers, we get 3 digits as the solution. And ones place is the ones place as it is. Right? Let's solve few more questions. 47 into 11. 47 into 11 is again a 3-digit number. 1, 2, 3. How will we do this? The ones place is 7. So ones place is fixed as 7. What is in tens place? 4 plus 7. What is 4 plus 7? 11. So 1 comes, 1 is carried. And what is in tens place actually? 4. So plus 4. 1 plus 4 is 5. So 517 is the solution. Clear? One more question. 63 into 11. 3-digit number. So ones place is 3. So the ones place should be 3. What about the tens place? 6 plus 3 is 9. So 9 in the tens place. And what is the hundreds place? The tens place of the digit is 6. So 6 into 1 is 6. So 693 is the answer. So I hope you understood how to multiply 2-digit numbers with 11 easily. Now let's look at how to multiply 3-digit numbers with 11. Multiplication of 3-digit numbers. This also follows the similar pattern as 2-digit numbers. Let's see. We have 294. Now on multiplication we get 4-digit numbers. Clear? And what are these 4-digit numbers going to be? We'll see now. Always the ones place will be the ones place of the number. This is fixed for 11. So this is going to be 4. No change in this. Now tens place is again the same pattern is followed. 9 plus 4. And what is 9 plus 4? 13. So 3 here, 1 carried. Next, hundreds place is 2 plus 9. 2 plus 9 is 11 and we already have 1. So this becomes 12. So 2 here and 1 here. Right. And then coming to the thousands place 2. What is the last digit? 2. And we already have 1. So 2 plus 1, 3. So the solution is 3, 2, 3, 4. Clear? This is how you will multiply for 3-digit numbers also. So to get more clarity, let's solve one more question. You see, I did not do any calculation, but I got the answer easily. Right? Now let's do for the 693 into 11. 693 into 11. Again we get 4 digits. First digit is going to be the ones place. So it is 3. Now, what is tens place? Good, you might have guessed already. It is 9 plus 3, 12. So 2 here and 1 carried. Then, what is the hundreds place? 6 plus 9. 6 plus 9 is 15 and I already have 1. So this is going to be 16. So 6 and 1. Now, the thousands place is the 6 plus 1, 7. So 7, 6, 2, 3. Looking at how to multiply 2-digit numbers and how to multiply 3-digit numbers, I hope you got the pattern to how to multiply big numbers, even 10-digit numbers by 11. It's the same pattern that we follow. Right? Now it's a task for you. Try to multiply 6, 7, 5, 4, 3, 2 by 11. Guess the pattern and try to multiply it with 11. And we can interact about it in our weekend session. So let's move to the next question now. Next, we will explore 3-digit numbers by 11 some more. Okay? So these are also your practice questions. So 524 into 11. I'll do one for you and one more for you as a homework. So 524 as 11 as we have done till now. How many digits will we get? 4 digits. So 1, 2, 3, 4. And what is the ones place going to be? The ones place of the number, that is 4. So 4. And what is the tens place going to be? Sum of the digits 2 and 4, 6. What about the hundreds place? It's sum of 5 and 2, 7. And then what about the thousands place? It is just the biggest number 5. I mean the number in hundreds place, which is 5. Clear? So 5, 7, 6, 4. Try to solve 105 into 11 as your homework. Okay? Yeah. 29 into 21. So how will we multiply such numbers? So multiplying by 11 and multiplying by 5 are done. Now we have random numbers, and how are we going to multiply them easily? Let's look into that now. So here we have 29 and 21, and it's quite easy. So 9 into 1. Let's look at ones places first. 9 into 1. That is 9. So 0, 9. We'll put it as 0, 9. And we have 2 and 2. Whatever number you have, add 1 to it. So 3. 3 into 2 is 6. So this is going to be 609. Clear? Let's look at one more example. 63 into 67. What are the ones places here? The ones places are 3 and 7. And multiply 3 and 7. We get 7 3s 21. So 7 3s 21. And then 6 and 6. Instead of 6, we'll add 1 and it becomes 7. And then what are we doing? We are multiplying 6 and 7. 6 7s 42. So the answer is 4221. Clear? This is 4221. And this is how we do. Just have a look at it once. Let's solve few more problems of this kind now. Find the product of 69 into 61. Again, 9 into 1 is 9 and we have 0, 9. Always remember, if it is a single digit number we get in product, we put 0 also. So this is going to be 0, 9, right? And what about 6 and 6? As I already told, when you have 6, take 7. 6 7s 42. So 4209 is the multiplication product. Clear? One more question. 7 into 3, 21. 7, so you have to take it as 8. 7 into 8 is 56. So 5621 is the multiplication product. Without doing all the calculations, I am getting the answer so easily. Let us solve one more question. 42 into 48. What is going to be the solution of this number? One's digits are 2 and 8 and we know 8 2s is 16. So this is going to be 16. I have 4, so what should we take? 5. Now 5 into 4, 20. So 2016 is the solution. So this is going to be a simple and useful trick for you to solve your math quickly. Let's look into the next slide now. Again, Ritu is here. And what is Ritu's doubt now? Wow, this is very simple. Okay, so she's happy with the methods we have given her. But can I use multiplication for any numbers? This trick which we use now, can it be used for any two-digit number multiplication? No, this cannot be used for all. There are certain conditions where we can use this. Let's look into those conditions now. Okay, so the first condition is rule 1. Numbers in tens place must be same. If you have observed, all the numbers given are 27 into 23, 61 into 69, 54 into 57. If you see, in all the cases, the tens place digits are same. 6, 6, 5, 5. So that is one of the important condition. This condition is satisfied, then rule 1 is satisfied. And is this enough? No. There is rule 2. And what is rule 2? Sum of digits in units place must be equal to 10. Is that happening? What is the number? 61 into 69. We had this number. So yes, tens place is satisfied. What about the ones place? In ones place we have 1 and 9. And 1 plus 9 is equal to 10. So yes, if this is satisfied, we can use the trick we have already used. Okay, so let's check for what numbers we can use it and for what numbers we should not use this trick. So 54 into 55. So yes or no, can I use the trick we have used till now? Tens place we have same, but what about 4 plus 5? 4 plus 5 is 9. It's not equal to 10. So no, I cannot use the trick in this case. Let's go for the one more number. What about 46 into 44. Well, in ones place, in tens place we have 4 and 4. Yes, first rule is satisfied. What about rule 2? 6 plus 4 is 10. So here you can use the trick, and what will we get the solution as? 6 4s are 24. Again you have 4, so 5 into 4. 5 4s 20. So 2024 is the product. Yes, I hope you got the trick and the rule when we can use the trick. Yes, so hoping that you had fun in this. Now I have few more questions to solve. 54 into 56. So first of all check, can we solve here using the trick or not? How will we check? Tens place is same, rule 1 satisfied. What is rule 2? Rule 2 is sum of ones place should be equal to 10. 4 plus 6, is it equal to 10? Yes, it is equal to 10. So we can use the trick, and on using trick, 4 into 6 is 24. So 24, we have 5 into 5. So this is, we'll make it as 6. 6 into 5, 30. So 3024 is the product. Next question. Tens place are 1. 8 plus 2 is 10. So rule 1, rule 2 satisfied. So we can use the trick here. So 1 plus 1, so 1 into 1 and 18 into 2. So 8 into 2 is 16. And then what should we do? We have 1 into 1. So we'll do 2 into 1, which is 2. So 216 is the solution. And this is how we can use math and play with it. There are several tricks, and these are the tricks that I have given you in this session. Right? Before concluding this session, let's learn few facts on math, that is on geometry. Okay? So yeah, he is John, and John is very happy knowing the tricks, and he wants to explore math more. I hope even you want to explore math more. So I'll conclude this session by saying 2 more facts to you. So the fact 1, what are these? We have circle, triangle, rectangle. We also have square, trapezium, different shapes. Okay? We have different shapes. And the fact of the day is that among all shapes with the same perimeter, what does perimeter mean? Perimeter is the outline, the measure of outline, the length of this outline, or we can also say sum of all the sides. We can also say sum of all sides. So for suppose perimeter is same for all the 3 shapes, then the largest area is by the circle. The largest area is always by the circle. That is what the fact. So if all shapes are of same perimeter, largest area is by the circle. Then what if all are of same area? If all are of same area, then shortest perimeter is to the circle. Its perimeter is shortest. If all are of equal area, then the perimeter of circle is shortest. Right? So these are the 2 facts. You can try these 2 by taking different perimeters and different areas for different shapes. You can try it as an activity at home and come up with different innovative answers that you got in the interactive sessions. Clear? So one last interesting fact on 0. On 0. What is that about 0? 0 is very special to us. Like this is invented by Indians. So 0 has no value if it is on the left. 0 has a value if it is on the right. 0 is very special. It is neither prime nor composite. Several things to it. And there is one more specialty of 0. That is 0 is the only number that cannot be represented using Roman numerals. We represent all the numbers using Roman numerals. Even if it is 100, we write it as C, right? If it is 10, we write it as x. And for all the numbers, even million, trillions, we represent it using Roman numerals. But 0 is the only number that cannot be represented using Roman numerals. Yes, so I hope you enjoyed all these facts, and with this I'll be concluding today's session. Thank you. Stay tuned.
Hello everyone. So now we'll be discussing about two interesting instruments. Okay, interesting light instruments you can call them. One is periscope and the other is kaleidoscope. Okay, so my name is Shashin Reddy. I'm a graduate from IIT NEET. Let's go into the class. And before we go into those two topics, let us once again revise plane mirrors. In fact, we'll revise what just the characteristics of the image formed by a plane mirror. Okay, so first of all, very quick revision. One is what? Image is upright or erect. Yes or no? See, head and head, both of them are at the top. The head of the image is also at the top. That means it is erect. Okay, or you say it is upright. Then it is virtual. What does virtual image mean? Quickly recollect. What does virtual image mean? Virtual image will mean an image where rays do not actually meet. Yes or no? So, in the case of a mirror, the image is virtual. Rays do not actually meet. Image is laterally inverted. Very important. What does laterally inverted mean? It means right becomes left and left becomes right. Yes or no? Right becomes left, left becomes right. Then, image is of same size as the object. If the height of object, let's say, is 100 centimeter, the size or the height of image will also be 100 centimeters. Then, image is at the same distance from the mirror as the object is from the mirror. What does this mean? This means that if this is the mirror, here if this is the object, and if this is the image, then if this distance is, let's say, 50 centimeter, this distance will also be how much? 50 centimeter. That's what the last point means. Image is at the same distance from the mirror as the object is from the mirror. So some important points regarding what? Regarding the image formed by a plane mirror. Let's go into a few questions, shall we? So the first one is here. The distance between the object and its image formed by a plane mirror appears to be 10 meters. What is the distance between the mirror and the object? Now, to understand such questions, it's better to draw the diagram first. So let's draw the diagram. This is the mirror. Let's say this is the object O and this here is the image I. Read this. The distance between the object and its image will mean between O and I, object and image, the distance is how much? Appears to be 10 meters. So this distance is how much? 10 meters. Then what is the distance between the mirror and the object? So we have to find out this distance. Now let's say that distance is D. How much? D. We don't know, we'll call it as D. But according to the properties of image, if the distance of object from the mirror is D, then the distance of image from the mirror will also be D. So here it is D, here it is D, D and D. So what is the total distance between object and image? It will be D plus D. What is D plus D? D plus D, it is equal to 2D. And that 2D is given as 10 meters. 2D is given as 10 meters. So how much is D? How much will D be? D will be 5 meters because 2 into 5 is equal to 10. 2 into 5 is equal to 10. So in place of D, you have 5. So D is equal to 5 meters. So if you draw the image, things will be easy. If you draw the image, things will be easy. And the answer is option C, 5 meters. Option C, 5 meters. Clear? Good enough? Okay. That's good. Very simple question. As I told you, the main priority will be to draw the image. It will make things pretty easy. Good. Now, next question. Image formed by a plane mirror is real or virtual? Image formed by a plane mirror is real or virtual? What do you think? And it is virtual, simple, straightforward. You have to remember it. Yes or no? It is virtual, because even if you go into the ray diagram, let's say this is the ray diagram, the mirror, this is the object, right? So one ray will be normally incident. What happens to it? It directly goes back. Yes or no? Okay, let's say here is the image. I'll take another ray. It will also undergo reflection. Yes, yes, okay, and then it will be reflected like this. So look at the reflected rays, only one reflected ray is going away, going up, and the other is going like this. Are they meeting anywhere? No, they are not actually meeting. When we extend them back, then they appear to meet. Appear to meet. Yes. So wherever the rays appear to meet, the image formed will be a virtual image. Good? Okay. Next. Another interesting question. If an object has moved 10 centimeters towards the mirror, how much distance does the image of the object move? Now again, you have to what? You have to draw a diagram. So let's draw the diagram first and then understand the question. This is the mirror. Let's say the object is initially here. And let's say the image is somewhere here. I'll take an example. Let's say this distance is 50 centimeters. The distance of object from the mirror is how much? 50 centimeters. Then the distance of image from the mirror will also be how much? 50 centimeters. Simple enough? Okay. Now, the object has moved. Look, read the question. The object has moved 10 centimeters towards the mirror. So now let's say this is the new position of object. I'll call it as O dash. So the object has moved how much distance? 10 centimeters. Look at the arrow. It is towards the mirror. Towards the mirror. Yes? Okay. Now when the object is here, what is the distance from the mirror? We need this distance. How much is it? Yeah, everyone, we need this distance. How much will it be? It will be 50 minus 10, 40 centimeter. It will be how much? 40 centimeter. Yes or no? Right, 50 minus 10 is 40. From 50 you subtract 10, you will get 40. Good. So if the object is here at O dash, where will its image be? Same distance. So distance of object from mirror is 40. So distance of image from mirror will also be how much? Will also be 40 centimeter. So let's call this as I dash. So look at the image. The image was first here, then it has come to this position. So how much distance did the image move? How much distance did the image move? Image has moved from I to I dash. So how much is that distance? See, this complete distance is 50 centimeter. This is 40. How much will this be? This will be 50 minus 40. How much? 10 centimeter. So the object has moved 10 centimeter. The image has also moved 10 centimeter. But the image, look at the direction. It has moved towards the mirror. Yes or no? This is towards the mirror. I can say this is towards the mirror and this is away from the mirror. It has gone towards left, and left in this case, this is mirror. It has moved towards the mirror. Yes or no? So the distance traveled by image will be 10 centimeter towards mirror. So what can you notice here? What we can notice is distance. Just a minute, I'll just write it down. Distance moved by image will be equal to distance moved by object. Distance moved by image will be equal to distance moved by object. Simple, is that clear? So remember this will always help you. We are coming to this point from a question, but this will help you in many such cases. Okay? And the answer is what? The answer will be 10 centimeter. But you have two options, 10 centimeter, 10 centimeter. One is towards, the other is away, but we already got it. It is 10 centimeter towards the mirror. 10 centimeter towards the mirror. Understood? Good. Chalo. So that's about mirrors. Okay. So we have revised a few the few properties and also went into a few questions. Now we'll go into periscope. Okay, so there's an interesting question here. What is that? Interesting situation. We have a submarine here and you have a ship floating on water. Submarine is inside water, ship is floating on water. So how can a submarine watch who is on the surface of water without coming up to the surface? How can it watch? That's an interesting question, right? So for that we use something called as periscope. We use something called as periscope. So this, you can see this, right? That is the periscope. But how? Look at that. This animation will show it to you. This green color dotted line, you can think of it as light. So light from the ship will enter this pipe-like thing. And see, inside that pipe-like thing, it is going down. It is initially going towards right, then it is going down. But light cannot easily change the direction. So something should have happened there. What should have happened? Reflection should have happened. And how? Mirrors do that reflection. So in a periscope, there are mirrors. But how do they do it? Let's also learn about that. Okay, let's go into detail regarding periscope. So in a periscope, all that we will be using is two mirrors. As you can see, let's say this is mirror 1, mirror 2. Only two mirrors. And the speciality is, these two mirrors will be parallel. They will be parallel. Do you know about parallel lines, everyone? See here, if I take these two lines, are they meeting? No, they are not meeting. But if I extend them, will they meet? Will they meet if I extend them? Yes. Right. And here if you look at the distance in this case, let's say here the distance is 30 centimeter. Here the distance obviously will not be 30. It could be, let's say, 20 centimeters. So the distance between the lines is not constant, and in that case, if you extend them, they will meet. But if I go into this case, where I take two lines in this way, where the distance between them, let's say here it is 5 centimeter and here also it is 5 centimeter, that is the distance between the lines is constant. 5 centimeter, constant. Then even when you extend them, you can extend them for however long you can. I mean, for 1 meter, 1 kilometer, 1000 kilometers, does not matter. They will never meet. They will never meet, and the distance between them will be constant everywhere. 5 centimeter, 5 centimeter, 5 centimeter, 5 centimeter, 5 centimeter. And those lines are called parallel lines. Parallel lines. And that is max. This is max. You'll learn about that, or you might have already learned about it in max. I'm just giving you a recollection. Okay, so here what we will do is, in a periscope, we'll take two mirrors, but we'll keep them parallel. That is the most important point. We take how many mirrors? Two mirrors. And how are they placed? They are placed parallel. And see what happens? When light falls on mirror 1, obviously mirror reflection takes place. So you can go for the loss of reflection, and it will come down. It will be arranged in such a way that it will come exactly down. And then here at the mirror 2, again what happens? Again it will be reflected. So two reflections take place. That means direction changes twice. Once, twice. So two mirrors, two reflections, direction changes twice. And the mirrors are parallel. So periscope will be something like this. As you can see, this is mirror 1. This is mirror 2. So this is the light reflected, reflected. Here the arrow should have been like this. Okay, my mistake. Let me draw it. So here what happens? This person can see what is above, what is at a height, without being discovered. Without being discovered. Okay, now this periscope is not only used in submarines, it is also used in tanks, for spying purpose also. Even for spying, we use similar technology, periscopes. Okay, interesting, right? You can make it. All that you need is what? Two mirrors. If you have two mirrors, can you make a periscope at home? You can. But you have to be careful that they have to be parallel. So try making a periscope. It will be interesting. You can spy around. You can become a spy agent for a day. Yes? So please try making it. A fun activity. Fun science project. Good. Next. The same periscope. Periscope contains two mirrors and they are parallel. We discussed them. Okay? Okay. Now another interesting thing. The periscope, a simply homemade periscope, you can see. Here the person's face is here, but we are seeing it from here. Like a periscope. Yes or no? We are seeing it from here. That's how it works. Can you see his face here? You can. Yes or no? Periscope. Good? Okay. So a simple question for us. Regarding periscope, how many minimum mirrors does a periscope need? Minimum. 1, 2, 3, 10. How many minimum mirrors does a periscope need? How many? How many did we use? We used 2. So minimum we will need 2. Maximum it's up to you. But minimum we need 2 mirrors. Got it? Good. Another interesting question. Which arrangement of mirrors is correct for a periscope? You have options A, B, C and D. In every case you have 2 mirrors each. So please select the correct answer. A, B, C and D. Which arrangement of mirrors is correct for a periscope? A, B, C and D. Everyone quick. You have to be quick because it's very easy. And the correct answer is option A. The correct answer is option A, because the mirrors should be parallel. Here they are parallel. Here they are not parallel. Here they are not parallel. And here also they are not parallel. Okay, parallel will mean they are along the same direction. Looking at it, you can identify. This is inclined, and both of them are in the same direction. They are parallel. Option A. Okay, good. Then we discussed about periscope. Then we'll go into something called as kaleidoscope. Okay, now this kaleidoscope is very interesting. because I'll directly go into the final slide regarding kaleidoscope. So look at these images. Are they interesting? Are they beautiful? Are they good? Can you see them? They are good, right? They are mesmerizing, in fact. Right, and that is possible using the instrument called as kaleidoscope. Using the instrument called kaleidoscope, and it's very easy to make. Obviously, you need mirror for that. You have to cut mirror carefully. I'll explain that. Okay, again, so another instrument, interesting instrument, we can make at home. You can make it as a science project. So please try. Okay, so take a cylinder shaped object like this. This is a cylinder shaped object. It's like a roll, okay, a roll, a hard roll, that's it. Okay, if you need an example, there is toilet paper, right? So toilet paper will be wound on this, a cylindrical cardboard. You can make use of it, very simple. Then, and cover it with a sheet of colorful paper. Now this we are doing for decoration purpose, so that our kaleidoscope appears good, appears beautiful. That's it. And secure the paper with tape. So basically, you take the cylindrical object, cover it with a blue color, any nice whatever color you like, blue, green, yellow, any color you like. Just wound it and secure it. Matlab, you have to paste it so that the paper will stick with a tape. That's not the main part. This is decoration. The main physics, the main science part will be now here. You have to take 3 mirrors. What you have to do is cut 3 mirrors in the shape of rectangles. Like this. Rectangular strip. You have to take 3 equal size. Again, equal rectangles. All of them should be equal. And then you have to place them. You have to place them in this way. Can you see? 1, 2, 3. Like a triangle. You have to place them like this. You have to make a triangle out of it. Okay? And arrange them in the shape of triangle as shown. Many are shown here. See? Inside you have the mirror. Where do you have the mirror? Inside. Okay? Not on the outside surface. Inside. The mirrored sides should be facing each other. That's what I'm saying. They should be looking at each other. They should be inside this. Okay? And then after that is done, it's very simple. Insert the mirrors in the cylindrical roll. There is a roll inside that we are inserting it. I told you, for decoration purpose. Right? And then all that you have to do is using that kaleidoscope that you have made. At one end of the kaleidoscope, if this is a kaleidoscope, this is kaleidoscope, at one end place any colorful object, any colorful object. Here they have placed a green color object, here they have placed an orange color, here black, here yellow. Just place it and look from the other side. And look from the other side and you can see different colors and it will be beautiful. Okay? And look at it from the other side, that's it. See, kaleidoscope is also very easy. Finding the mirror part will be difficult. Instead of mirrors, what you can do is you can take a smooth aluminum foil. It will not work perfectly, but it will give you an idea. If you don't find mirrors, in place of mirror, you can make use of what? A smooth aluminum foil. Whatever reflects. Aluminum, very smooth aluminum foil reflects. You can do that. Will not give you a perfect kaleidoscope. Mirror will be perfect. But yeah, it will still work. It will give you an idea. If you cannot find a mirror, you can go for a smooth aluminum foil. Good? Kaleidoscope. Simple as that. Okay? Okay. Now there is one more topic. That is multiple images by 2 mirrors. Look at this. We have one ring. And how many images? At least not one, we have multiple. Multiple will mean more than one. You have one image here, second image here, third, fourth, fifth, so many images. You have multiple images. How many? Multiple images. And how do we get this? If you use one mirror, you will get only one image. But we are using how many mirrors? See, this is one mirror, this is the other mirror. So we are using 2 mirrors. How many? 2 mirrors. So using 2 mirrors, you can get multiple images. And a very practical example of this, whenever you go shopping to buy clothes, Okay, going to the dressing room. In the dressing room, here there is one mirror, here there is one mirror. When you look into this mirror, you can see multiple images of yourself. When you look into this mirror also, you can see multiple images of yourself. Yes or no? And how many mirrors are used? Minimum 2 mirrors are used, and then you can see multiple images of yourself. Right? So, how many images you see will depend on the angle. Will depend on the angle between them, the angle, this angle between them. You might be able to see 2 images, 3 images, 4, 5, 6, 7, 8, 9, 10, until infinite. As many as possible. It all depends on angle. Okay, so when 2 mirrors are inclined with each other, multiple images are formed. Got it? So a very simple case you can see here. This is mirror 1, this is mirror 2. In between them an object is placed, a very small object, and this is the angle between them. And how do you find the angle, everyone? Angle between 2 lines, how do you find them? Using a protractor. So even the angle between 2 mirrors you can find using what? Using a protractor. So depending on the angle between the 2 mirrors, different number of images are formed. Now here for this there are mathematical formulae. Yes, but do we need formulae? No, we will learn that later on. So what will you learn now? What you will do is just take 2 mirrors and you yourself try it. Keep it at different angles. You can keep it like this, you can keep it like this, you can keep it like this, you can keep it like this. Up to you. It's like a game. So keep experimenting with it. Try with different angles. And see, or else count how many images will you get. How many images will you get? Try it along with your friends. It will be good. Okay. This example I'll explain is just a statement. So I'll just give you an idea. For 2 images. Okay. For 2 images, the angle should be 120 degrees. So the mirrors should be placed something like this. Then the angle between them will be 120 degrees. Just remember it, okay? I mean, remember in the sense, how will you do this? How will you remember? What you will do is take and play around with it. Play with it. So keep 2 mirrors at 120 degrees. How will you make 120 degrees? Using a protractor. And then keep an object in between and see how many images you will get. Should get 2 images. For 3 images, it would be 90 degrees perpendicular. Okay, for 4 images, you can go with 72 degrees. 72 will be something like this. Okay, this much is enough. So try playing around with it. Just do it. Okay. For 72 degrees, here, I mean, this is a special case. For 72, you can get 4 or you can also get 5. Okay. 360 by 72 is 5. So you'll get either 5 or 4. So just play around with it. And sir, let's say, I've kept it randomly. I've kept it like this. And I'm getting 5 images. Will the angle always be 72? Or let's say I'm getting 4 images. Will the angle always be 72? No. It can change. Now there are formulae for it. But it's not up to your level now. You will learn that in higher grades. So what you will do is just play around with it. Play around with it and you'll understand. Okay, but the point that you have to understand now is this. Depending on the angle between 2 mirrors, different number of images are formed. So do it. Place 2 mirrors at 120 degrees. See how many images you get. You should be getting 2 images. 90 degrees, you should be getting 3. 72, you should be getting 5 or 4. In fact, here also you'll get 3 or 2. Sir, why 3 or 2? The answer should be either 2 or 3. It depends on where you keep the object. There are many factors. That's why I'm not giving a perfect answer. It depends on where you keep the object. Ultimately, it's to play. So play around with it. Okay? Okay. So, and this I'm just using a protractor to remind you how to measure angles. Yes or no? If you have 2 lines, here 0, here 30, the angle is 30 degrees. Then here 0, here 45, angle is 45. 0, 60, 60 degrees. 0, 90, 90 degrees. 0, 120, 120 degrees. 0, 180, 180 degrees. So just play around, okay? You know how to calculate angles. So keep the mirrors at different angles and do it. Okay? Good. So that's it, everyone. We learned many things in today's class, many interesting activities. Periscope, you can try that at home. You can make it at home. Kaleidoscope, you can, and multiple image formation using 2 mirrors. So try them all. Okay, so thank you. Thanks a lot.